All right, part 2. We're now going to simplify some more radical expressions, but these are going to be a little bit more difficult. All right, they want us to take the square root of 30 and take the square root of x to the third. All right, now, you can't actually take the square root of 30. It is not a perfect square. I can see if it simplifies. This is how I taught my kids last year. I do the like L instead of the tree branch to see the factors of 30. But, okay, I know 1 times 30 is 30. I could break it apart into 2 times 15. And then 15 further breaks apart into 3 times 5. And then I have 5, and I can't break that apart anymore. All right, so that means these on the outside that makes the L shape, those are the prime factors of 30. All right, now there's not a pair. There's not a single pair, which tells me that this does not simplify at all. So I'm actually just going to leave it alone as the square root of 30. Now, this square root of x to the third, all right, if we rewrite it as we did before, where we had it as a little divide part, well, square root means you divide by 2. Okay, we actually are going to simplify this. I want you to think of it as how many times does 2 go into 3, and then what is the remainder, all right? So 2 goes into 3 or divides into 3 one time. So we are going to have an x to the first that's actually going to come outside in front of the radical. That would also leave 1x left over, all right? A remainder. Remainders or leftovers are always going to stay underneath the radical. Actually, this is too close. I need to rewrite this. So my final answer here would be x, square root of 30, x. These are both to the first power. All right, now let's look at b. Okay, on b, we're taking the cubed root. We take the cubed root of 81. We're going to take the cubed root of y squared, and we are going to take the cubed root of z to the fourth. Okay, I can rewrite this. I can take the cubed root of 81. It should be, I think I could take the cubed root of 81. No, I'm not sure. Let's see. All right, let's do my little L tree. Okay, so 1 times 81, I can't divide it by 2. I can divide 81 by 3. That would be 3 times 27. I can break 27 apart into 3 times 9. And I can break 9 apart into 3 times 3. All right, but I can't break that apart anymore. So my L here, this is my prime factorization of 81. Now, since I'm doing cubed root, I'm looking for triples. I'm looking for 3 of the same number. So because there are 3 3s, all right, there is a triple of 3s, I can simplify that. I'm going to have a 3 come in front, and then whatever's left over, which is a 3 and a 1, stays on the inside. But they multiply back together, and we know 3 times 1 is still 3. Okay, so you can reduce or simplify the cubed root of 81. It simplifies into 3, the cubed root of 3. All right, now for the y, that would be y to the 2/3. All right, because it's cubed root, we divide by 3. For the z's, it would be z to the 4/3. Now, thinking about what we were doing in this first example, does 3 go into 2 at all? No, it's not big enough, okay? So it goes in there 0 times. So we aren't going to have any y's that come out front because it goes in there 0 times. But what that means is we now have, we have 2 that are left over. All right, we'll have the y squared still left over, which means it's just going to stay on the inside of the radical. All right, and then we've taken care of that part. as far as the z's. 3 divides into 4 one time, which means we are going to have a z to the first because of that one time that's going to come out to the front, right? And that would still leave us with 1 z left over, right? Because there were 4 of them, would leave us with 1 z left over that would stay on the inside. Okay, so a z to the first on the inside. I need to rewrite this because I didn't have enough room to write it all out. So in the front, we had a 3, we had a z, then we have our cubed root sign, then we had a 3, a y squared, and a z to the first on the inside, and this would be all we could simplify it. Okay, let's look at C. Okay, we are going to take the 4th root of 32, the 4th root of s to the 7th, and the 4th root of t to the 12th. All right, so I'm going to do the prime factorization for this. So 1 times 32. I go to the next number, lowest number that's prime that I could think of. So actually 2 times 16 makes 32. Now we're going to break apart 16. 2 times 8, which is 2 times 4, which is 2 times 2. And I can't break that apart anymore. Here's my L. Those are the prime factors, right? Because this is a 4th root, we're trying to see if there are 4 of a kind, all right? And there are actually 4 2s, which means that we're going to have a 2 that is able to break free and come out to the front. So we're going to have 2, 4th root, and the leftovers, 2 times 1, all right, stays on the inside. Okay, now that takes care of this part, all right? The s to the 7th, that would be s to the 7 divided by 4. How many times does 4 go into 7? It only goes in there 1 time, all right, which means we're going to have an s to the first that breaks out in front, and there would still be 3 s's left over. So leftovers are always on the inside. We have s to the 3rd left over on the inside, all right? As far as the t's, okay, this would be t to the 12 divided by 4, because it's a 4th root. That divides evenly. It's t to the 3rd, all right? Whatever does divide comes out to the front, all right? So we're also going to have a t to the 3rd that comes out in the front, and there are no leftovers. There won't be any leftovers, so no t's will be left on the inside. Now let me rewrite that. I have a 2 in front, an s to the 1st, and a t to the 3rd that are all in front of the 4th root, all right, with a 2s to the 3rd on the inside.